Alrighty, so we talked a lot about scatter plots. We talked about how to interpret them. We talked about how to make them. We talked about our relationship between the two and looking at our correlation coefficient versus causation. We took a look at lots of different things. And the one thing we did take a look at, the previous lesson, this is the last thing that we're take a look at, but previous lesson was our least squares regression line, where we're trying to find the line of best fit through the data points. And we let our calculators kind of calculate our slope and our y-intercept and all that stuff. Now, no line that we talk about with our least squares regression line has actually passed through every single point so far. That means that we have our prediction values from our least squares regression lines, from our response, that are still have some error from our y values. So because we use a line to predict our y from our x, the prediction errors that we make in y are in the vertical direction. So it's always going to be away from our line. So we're always going to take, look when we have a line, maybe we have a point here, we're looking at the error that is between the point and the actual line of best fit or least squares regression line. Or we have maybe one point that's lower, and then we have kind of that error in the vertical direction. Now, a good regression makes the vertical deviations from the point of the line as small as possible. So we want to make sure that we don't have like a point that's way up here and we have this vertical distance that's super, super long. So we want that from the line to be as close or as small as possible. So our residual, think of like this is the residual data that's left over from our estimations, from what actually happened to what we're trying to predict is going to happen. Residual data is the vertical distance. So that's what a residual is. It's the vertical distance between the observed value and then of the response variable and then the value that we predicted by the regression line. Just like this. This is our residual right here. That's our residual. That's our residual right there. So here's our line. Here's what actually happened. That's the distance from, that's our kind of residual point or residual from there. To get that, all we have to do is take our observed value and we subtract whatever we predicted. Or, in layman's terms, to find our residual, we're going to take our y, so what actually happened, minus our predicted, remember the y with the little y hat. So that's our predicted value. If the residual is positive, that just means that the observed line or observed point lies above, meaning what happened was actually greater than what we predicted. If the residual is negative, then the observed value or observed point lies below the least squares regression line, meaning that our y value was less than what we predicted. And we'll have some points above, some points below. We want it to be right through the middle of the data. That's what is a good line of best fit or a good least squares regression line. So, fun fact, if you add up all the residuals in the data, you're going to get zeros. And this is why the method of the least squares regression, it involves squaring the residuals. So we take all our residuals, we take our y minus our what actually happened minus what we predicted happening. We square all of them, and then we add them all up to minimize that value. Think about it. Squaring residuals. This is our square. And we're minimizing, so it's our least squares regression line. So that's how we get least squares regression. All right, so we are going to look at an example and calculate the residuals. So looking at my example here, we have the data falls below, or data below shows that the fat content in grams and the number of calories of 8 items off the Taco Bell's dollar menu. So we got our cheesy double beef burrito, we have our fat and our calories of each. We're going to do a equation of our least squares regression. So very first thing you have to do is get your handy dandy calculators out. And we need to type in all of our data into our list 1 and list 2. So we're going to try to see if the fat content is going to explain our calories. So our fat is going to be our X, our calories is going to be our Y. So go ahead and take a minute. Remember, you got to hit Stat, Edit to clear out your list. You scroll up to L2, you hit Clear, Enter. Scroll up to L1, Clear, Enter, and it deletes all the data that's there. So go ahead and pause the video and do that right now. All right, we had 8 data points, so we should be on L2 9s. Remember, that's the 9th position in our second list. And make sure that you go across, remember, because these two go together. This resembles the fat and the calorie content for that cheesy double beef burrito. All right, so we're going to write our equation of our least squares regression. So we're going to use our calculator to do so. Remember, it's in the form of y hat equals ax plus b. So I'm going to have my y hat first because we're trying to predict our calorie content. And remember, you're going to go to your, move this up so we can see. So you're going to go to Stat again. You're going to go over to Calculate. And you're going to go down to number 4. I'm going to use number 4. You can use number 8. Doesn't matter to me. I don't care. However you want to write it works for me. We're going to go ahead and calculate through. All right. Because we have our AX, that's our slope, I'm just going to round to the nearest tenth. So we'll take 19.7x. And then we have our B value, which is plus 35 point, and we'll just round once again to the nearest tenth. So we'll say we're at 35 point. We'll do 7. All right, so in order to calculate some residuals and figure out all of those values, I'm going to clear this out. The very first thing that we have to take a look at is what did the observed data show that our calories are for our cheesy bean and rice burrito. So we're going to look at our cheesy bean and rice burrito. Cheesy bean and rice burrito. What actually we are looking at, it is 420 calories. So we actually know that it's 420 calories. That's what we know happened. That is our known observed value. The least squares regression predicts that it will have how many calories? Well, in order to figure out that, we got to figure out calories is going to be my Y. I know my fat content. So my fat content is going to be 16. So I'm going to plug 16 in for X and figure out what is going to be my predicted Y, which is my calories. So I have my Y hat is equal to, I'm going to take 19.7. And we're going to multiply that by 16 grams of fat. And we're going to add that to 35.7. So in my calculator, I'm going to take 19.7 in parentheses 16 plus 35.7. And we are predicting that we're going to have 350.9 calories instead. That's what my least squares regression is saying. So to find the residual, we're going to take what actually happened, so our Y, minus our predicted. So I'm going to take, I know that it was 420. We're going to see how much our data or our line of best fit or our least squares regression line is off by. So we take 420 minus my 350.9 calories. So I'm going to take my 420 minus 350.9, and I get 69.1 calories. So we're off by 69.1 calories. That is how far or how many calories our bar, remember these have these little vertical bars, is off by. That means that our point, because this is positive, is going to fall above my least squares regression line. And it's only because the residual is positive. So let's try another one. All right, so we have the observed data shows that the classic nachos has how many calories? So we're looking at classic nachos. Classic nachos calories is 220. So I know that we have 220 220 calories. Now, we want to see what our least squares regression line predicts. And remember, we have our least squares. It's y hat is equal to 19.7x. I'm just going to rewrite it so I don't have to keep flipping back and forth. 35.7. All right. So looking at the least squares regression line, what it predicts. So we're trying to find our y hat here when our x value. So we got to figure out how many calories or how many grams of fat it has. 13 grams of fat. So I have 19.7 times 13, and we're going to add 35.7 to it. And I'm looking at, I believe, typing this in here, 291.8 calories is how much we are looking at predicting wise. So to find the residual, we have our y minus our y hat. So what actually happens, our 220 minus our 291.8. And we're going to figure out what our residual is. So take 220 minus 29.8. I'm going to get negative 71.8 calories. So would this point fall above or below your least squares regression line? Well, it's going to fall below, because looking at below our line, because it's negative, it means our point is going to be below my least squares regression line. So I'm going to take a few minutes. I want you to do part B. So go ahead and pause the video and do that. Alrighty, so we know that the observed data shows that the cheesy breakfast burrito has 340 calories. When you're taking a look at your least squares regression prediction, so this is how you're going to check your answers here in just a second. We're going to take our y hat, we're going to take 19.7, and we know that it has 14 grams of fat. So that means that the predicted amount of calories is going to be 311.5. And then to find the residual, we're just going to take our 340 minus our 311.5, and we get 28.5 calories. So when we're looking at a positive residual, we know that our point should fall above our line. So you're going to get some time and some practice on this, and then the rest of the time is to do your makeup work if you need to.